Here's why I wanted to point out that pattern from the warm-up. Okay, we're going to be factoring a trinomial today. And we're going to be looking at quadratic trinomials that look like this. This is actually like an A, but we're only going to mess with A values of 1 today. So the coefficient, constant, A, B, C, just for organizational purposes. And these are going to factor into two binomials. So like for your warm-up and for the last lesson, you went from 2 binomials and simplified it into a trinomial, right? For most of them. We're going to, again, reverse that. And we're going to go from the trinomial to 2 binomials. Yeah. So, from that pattern we established in the warm-up, what we need to do is we need to get our 2 integers. So there's the 2 integers in our binomials. So like, for example, like we had x plus 2 and x minus 1 or something like that, right? The 2 integers, they need to add to be b and multiply to be c. That's the pattern we established in our warm-up. So they need to add to be b, and they need to multiply to be c. You see? So that guide example in your notes gives you the x squared plus 7x plus 12. So I think the best one to look at first is our c term, because I know it needs to multiply to equal that. There's lots of ways we can add to equal that, right? Multiply, add. What are factor pairs of 12 I could consider? Well, 1 and 12. 2 and 6. 3 and 4. Only one of these pairs is going to add to give me that b term, right? So I'm going to mess with 3 and 4. Okay? Those are my integers that have a product of 12 and a sum of 7. And why that's important is, boom, here's my binomial. That equals my trinomial. You can always check it by like, don't actually do the distribution, it'd be a ton of work. But here's your x squared, here's your 4x and 3x for your 7x, and here's your 12. Okay? Now let me tell you why you want to do this. Some of this might go over your head, but you'll see, like, that was not too hard to do. And if it was a quadratic equation, it looks like this, y equals this stuff. And I'll tell you, this parabola, Soldier Boy's favorite function, this parabola crosses the x-axis at 2 points, point negative 3, 0, and point negative 4, 0. And I can get that from looking at it. Now, you don't need to know how to do that until 2 more units. Don't worry about an 8. I got you in 2 more units. But I can just look at that and get this answer. Let me show you what you have to do if you do not do it this way. You have to look here, and you have to do this equation. Negative b plus or minus the square root of b squared minus 4ac over 2a. Yes. So that would be a negative 7 plus or minus the square root of 49 minus 48 of 1 over 2. So negative 7 plus 1 over 2, negative 7 minus 1 over 2. My answers are negative 3 and negative 4. No, I'm not saying, don't do this, don't write this down. Which way would you rather get your negative 3 and negative 4? Looking at this and being like, boom, negative 3, negative 4, or doing all this junk? Don't do all the junk unless you have to. Sometimes you have to. Sometimes it doesn't factor into 2 nice binomials. Don't worry about any of this yet until Unit 12.
Why was it negative 3 and negative 4 though?
Yeah, so I'm going to explain that to you in Unit 12. But I'll give you a quick little one. Here, let me pause the video. So the main idea is, if you can factor to solve a quadratic, life is easier. So I want to teach you how to factor, so that when you solve quadratics, I can make your life easier. Sounds nice when I put it that way. All right, so let's check out this trinomial. Number 1, we got n squared plus 9n plus 20. I know this is going to factor into 2 binomials, so I like to just be like, boom, get those out of the way. Okay, got the parentheses going. Okay. Then, I'll take care of the hard part for you, all right? I know I'm getting that n squared by an n times n. I got you. Don't sweat on that, okay? I know that one was, that's n times n, okay? Now, I need to multiply to get 20, but add to get 9. So I start rolling through factors of 20. 120, 210, 3 nothing, 4 5. Ooh, that looks nice. Yeah, doing the hard thing. Okay, plus 5, plus 4. There's my binomial factored from my trinomial.
Does it matter which one you put in the first parentheses?
No, because of the commutative and associative properties of multiplication.
Wait, I thought no.
Because you're going to have a 4n and 5n or 5n and 4n. Either way, 9n. Let's take a look at number 3. I've got a squared plus 10a plus 24. I want you to try that on your own, please. Let's check out number 3. I'll take care of the hard part. A times a, I got you, fam. Now, it needs to multiply to equal 24, but add equal 10. What are you thinking, Miles? 6 and a 4. There we go. Same thing. 4 and a 6, 6 and a 4. These multiply to give me my third term, 24. Add to give me my second term, 10. Let's look at number 5. Who can raise their hand and tell me what looks to be a little bit different about number 5? Nate, what do you notice?
They're negative.
There's the third term there is negative. Max, how do I get negative with it? Because I have to multiply to get that third term, right? So
you have to have one of your factors be negative.
yeah.
Like negative 3 times positive 6. Or times
Yeah.
negative.
So I'm going to baby step us there. So we need one. Do you guys see that? We need a positive and negative to get a negative third term, right? Then Max is saying, hey, if my middle term, if it adds to be positive, my middle term needs to come from a larger absolute value being positive. So Max was like running through those factors, and he's like, ooh, 6 and 3. And you can't just put these ones anywhere.
Yeah, it has
6 has to be positive, 3 has to be negative. Now, you could write it like this, and it's the same thing. Okay? This is cool. Same thing. But your 6 has to be positive, your 3 has to be negative. Otherwise, this will not be a 3. All right? Do you see how I took that bigger problem, broke it down into smaller problems again? Okay. So try out number 7 on your own, please. G squared plus G minus 6. All right, I'll take care of the hard part. G times G, okay?
so different.
Now, how do I get a negative?
When I write a negative sign.
No, one of each. I need a positive and a negative. So factors of 6, here's all of them. So how do I get a 1 result in a positive 1? Leah, how do I result in a positive 1? How do I get a positive 1 for my middle term here? What numbers do I have to use? A 3 and a negative 2, right? Okay. Are you guys seeing how to get there? And then you can always check it, right? Here's G squared. Here's negative 2 and a positive 3G for a G. Here's a negative 6. Cool. All right, let's look at number 9. Who can tell me what they notice is different about number 9?
2 negative.
2 negatives. So I'll take care of the hard part. But to multiply to get negative, we need one of each, right? But if I'm going to add to get a negative, which one has to have the larger absolute value? The negative does. So factors of 3. Let's put them all down. Okay, here, there they are. So how do I get a negative 2 out of that?
I have to be negative 3 plus 1.
3 negatives, 1 positive. That has to be my 2 binomials.
So Matt,
Yeah.
it doesn't matter what order you put the one in, correct?
Kind of. I could write it as this, but I can't mix the positive and negative nature of 3 and 1. Yeah. Good question.
Why is it a plus?
Because I did my extra credit. No, you could do either one of these works. There's an A minus 3. Does that answer your question?
You can't have a plus 3 though.
You can't have A plus 3 because then your absolute value would be too large and you would not get a negative second term when you combine your like terms. So it's different than the previous one, right? That second term tells us our larger absolute value has to be negative.
Oh, I get it.
Do number 11 on your own, please. Okay, I'll take care of the hard part, guys. I got you. B times B is B squared. Tyler, what should I try?
B plus 7, B minus 9.
Let's see. Does it multiply to be negative 63, guys? Yep. Does it add to be negative 2? Check. And what's cool about this is, this means it crosses my y-axis at these 2 points. My x-axis is what I meant to say. I can get that by looking at it. That's why. So you don't have to know this yet at all. Just this is one reason that we're learning it. Number 13. Who can tell me what looks different about 13?
There's a negative or a positive. The negative is in the B.
Ooh, so we have a negative b value but a positive c value. So let's take. I'll take care of this for you guys. I got you. How do I multiply, get a positive, but add, get a negative? What's got to be going on? They've got to be a negative times a negative, right? Adds to be more negative, multiplies to be positive. So I'm thinking factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Ooh, there it is. 3 and 8, right? They multiply to be 24, but they have a sum of 11. Cool? These are like a pattern. I kind of think we should make like a fun Sudoku book like these and just sell it.
What do you mean?
It's kind of like a puzzle. People like those Sudoku things because they're like a puzzle, right?
Yeah, but they don't have that.
Number 15. This one looks tougher. We got a 72. You guys seeing that minus minus action?
Wait, does it?
Multiplies to be positive, adds to be negative. So factors of 72, I got 172. I got 2 and 36. I've got 3 and 24. I've got 4 and 18. Nothing yet? 6 and 12. 8 and 9. Dang, I did all that work for it.
Does the
I wish
does
so.
the positive or negative only affect the B?
It affects B and C. Multiplies, adds. It's a good day to know your multiplication facts, friends. Yeah, Max. Y'all need to do 17, 19, and 21 on your own to see how you're doing. Let's do this. So on this one, I need one of each. Because it multiplies to be negative. I've got an 8 and a 2. The 8 has to be positive. Okay? Because the common, the B value there has to have the larger absolute value be positive. Number 19. I have an 8 times 5 there. All right. There's number 19. Multiplies to be positive, adds to be positive. Number 21, I need one of each. Okay? The negative has to be larger. So you can like mix up where your pairs are, where each binomial is, but the positive or negative would have to follow. Otherwise, you're going to get a different answer. One more type of problem to kind of look at. Let's look at 23. And it's no big deal. It looks scary, but it's not.
How is 23 scary?
So we get something like 23.
23. Very
And it's actually the same problem. So as I look at all three terms, you guys seeing that common factor I'm seeing? What is it? I'm seeing a common factor of 4. So I can actually factor that out. I can divide everything by 4 and get k squared plus 3k plus 2. What's cool about this is, do you see now that I have that trinomial with that leading coefficient of 1? Okay? So that means I'm going to be able to split that up into these two binomials. Once I factor out that 4, I can do this. So I've got a k plus 2 and a k plus 1. Yep, multiplies to be 2, adds to be 3.
Wait, is it the same thing that we've been looking at?
Yeah, but I needed to get this to be a 1, so I factored it out because I could. So once I factored out that 4, business as usual right there. Okay? So this, if you cross that out, same thing we've been doing.
Wait, but can't you just write, instead of just writing like K, can't you just write 2K inside the parentheses?
Not, it'd have to be k plus 2. Because if I distributed this, it'd take me back to this. And if I distributed this, it'd take me back to that.
So the 4 goes to both of them, not just the first one?
No, if I were to simplify this bottom version, I would multiply my binomials first. And I would do, which would give me this. Yeah.
These are technically 4
Yep.
times
So this right here is the answer of the factored trinomial.
all of it.
Let's look at 25. Okay, so what's a common factor of all these terms? Which is nice, because you want an a value of 1. Things get trickier when the a value isn't 1. So I'm going to factor out a 3. All right. Now, inside my parentheses is business as usual for today. I know I've got a y times a y for a y squared. I know that it has to multiply to be positive, but add to be negative. So those both have to be negative. So factors of 4, I'm only rocking 1, 4, 2, 2. Which one do I want?
4.
1, 4. Multiplies to be 4, adds to be negative 5. That's my answer. And again, we want this to be my answer because when we learned quadratics, y in this case can be 1 or 4. If you were to set up this with an equation, it would be negative b plus or minus square root of b squared minus 4ac over 2a. And then you'd have to simplify all that. You want to avoid that if you can. Sometimes you cannot. Next, number 28. Last one I want to look at with you. I'm going to get you lots of homework time today. 28 looks scary, but it's not. Don't be scared. All right, so I'm going to factor out a GCF again. So coefficient, what can I factor out? 5. Okay, variable-wise, what can I factor out? A y. They all have a factor of y. So if I factor out 5y, I'm left with a
28.
x squared minus 3x minus 28. Okay. Now do you notice that inside our parentheses we got a trinomial like we're used to messing with now? So I'm going to break that up into 2 binomials. I got an x times x. If I multiply to get a negative third term, that means I have to have a positive and a negative. Factors of 28. 128, 2, 14, 4, 7. How am I getting that 3?
7 minus.
Yeah, the 7 has to be negative, the 4 has to be positive.
Oh.
And that is that. So we're always going to end up getting some kind of trinomial with a coefficient of 1 today. Once you don't have a coefficient of 1, if you can't factor it out, things get trickier, so we don't go there yet. Okay. Cool.